Hello colleagues, I'm Igor Borodowski. I'm really glad to see each one of you today in our event. I hope you are well during those pandemic times, and we will spend a little bit less than an hour together discussing what do we have in our new nesting functionality for Woodwork for Inventor. So first I'd like to speak a little bit about what kind of nestings do we have, because we often getting some questions from our customers about what to do if we need to receive a saw nesting optimization. So in this case we can utilize Woodwork BOM to generate a list of rectangular parts. We need to just get a simple list with the dimensions and the names of the parts. Okay, so once we get the list of rectangular workpieces, we can send it to some third-party sawing software. I will not mention the names, but most of those rectangular cutting sawing machines may have some software which is embedded or shipped together with the machine, so they can include the data in form of the list of the rectangles and get the nesting on the machine. So what we will discuss today is a little bit another thing, is a free shape nesting. So that's what we use Woodwork for Inventor nesting for. Okay, so in this case we must get a set of CNC contours, and the drillings needed for each of the parts. Okay, now let's speak about the versions. What versions of a Woodwork we have and what they do, what is the difference between them, and what we did at the moment. So first of all, I'll just speak about regular Woodwork for Inventor, what we did so far to this moment. We fixed some minor issues, and we also added some improvements requested by our customers. The second version we have is called Woodwork for Inventor with CAM, and in this case we need to discuss what is the difference between nesting versions in this CAM product. Previously we had something called nesting beta. There was like a beta version, and it was a long time ago when we started to develop it to see how market reacts to those functions and so on. So finally we changed it to a nesting with the basic functionality, so we call it Nesting Lite, and it's free for the users. So if you're already using Woodwork for Inventor with CAM, you'll get this Nesting Lite update for free. Despite the name that it's called Lite, it's overweight the beta functionality, so we have more functions, more nice features in this Lite version than beta version had before. And finally we have a third version of which is called just Woodwork for Inventor with nesting. As the name tells, it has more powerful nesting functionality, and because of that it will be paid separately. So it's not free, it will be paid. So now let's see what those functions we have here. What is the differences? So first we will start with from the Nesting Lite, which is included in the Woodwork with CAM, and I differentiated the functionality by the color. So if you'll see some green text, mostly for a light version. If you see something in red, it's related with the most feature-rich nesting functionality. So first of all, let's take a look at the UI. We tried to refine the UI. We place the commands in the groups, so you can see we have some ribbon looking interface when all the commands are grouped by their functionality. So some of those features displayed here is not related with the light version only. Those features can belong to nesting, not light but nesting. But in general what we did so far, we changed the interface. Okay, and we hope that this interface will be more user-friendly than it was before. So one of the key features in this nesting release was the fact that we placed the options of the tooling in the side of the material definition. So how it was done before? Those of you who used nesting functionality in the previous version knows that we can define something like a nesting machine. We could do this in the previous version. Then we can assign tool and so on. But what is bad here is the fact that we cannot differentiate the tooling according to material properties. So from now on we can define individual tooling options for different material thicknesses, and as you can see on the right side, you can define the tooling options like raw material size, workpiece processing, oversizes, and moreover, of course, the nesting individually for each material and each thickness of that material. Okay, so as you can see here, we can define like what equipment we will use, what machine we will use, how to maintain the position. And that is something new. We can maintain the position of a small parts because they tend to move during the operation. So we need to keep them on place somehow. And one of those ways how to place them and keep them on a position is to leave a small thin layer, which we call onion skin, intact. So once this part is on the nesting stage, we just leave small residue of the part, and then it stays on the position during the tooling. So we have an option to define what is the size of the part that need to be kept on place during the operation using onion skin. Another option is to use bridges. So we can connect the parts together using bridges. Mostly it's used in cases when the part is a little bit bigger. Okay, so if the part is way bigger, then the bridge or onion skin is not needed at all. So we cannot avoid. We can just fix it on place using the vacuum mechanism. But if the part is smaller than some values, we can use bridges or onion skin to do to maintain the position, to fix the part on the place. And of course, last but not least, we can choose what is the processing options. Yeah, like in case before, you can see on the left we have all those options, even more of them. We can define what tooling to use and what options of those tooling operation we need to apply. Okay, so now let's see an example. Say that we have some type of the material. In this case, let it be a high density fiberboard, and then we can apply according tooling depending on the thickness. Say that we have 18, 22 and 30 millimeters of the HDF panel. So we can define some tools for each of those panels. As you can see, we just name them A and B, yeah? And we have the same tool for two different thicknesses. So what can be the difference? We may have some differences in the tooling options. Yeah, for instance, step over. Yeah, we can turn it off if the part is thin enough, or enable it and define what the step value will be. As you can imagine, this can be done for different materials, for MDF, for instance, and plywood and so on. You can apply different tooling options, which is very convenient. Okay, let's take a look how it happens in a real case. So all that happens in the material editor. We can expand the material type. You can see the plus nearby. This allows you to add the thickness. Okay, but if you just navigate in the dialog, you can see that we can choose the machine, define oversize options, and say that we will apply some configuration of a nesting. Since we have a lot of options here, we made some configuration mechanism which allows you to define the options of a tooling, and then you can apply those options on different materials. So for instance, I use the same tooling operations for HDF and MDF as well. Yes, so what we can do here, we can choose the equipment we will use, how we will maintain the position, and of course we can choose the processing options. Yeah, what is the direction of the tooling, what is the clamping corner, what margins should be kept, and so on, how to place the part, how to maintain their position by bridge, by onion skin, define the criteria, and define the machine options as well. Yeah, so in this case, let it be just a simple machine. So let's see what will happen in case if you add another thickness. So in this case, this option will be set for the panel range between 0 and 80 millimeters. All the rest will be kept as any type. Okay, so again, we can choose the machine, choose the configuration. Maybe one of those configurations we used before. Maybe we will change something. Yeah, so you can easily maintain the tooling by using configuration you predefined previously. Okay, so let's add another thickness, 24. Okay, so you can see now it belongs to the range between 18 and 24 millimeters. So we can choose another workpiece size, oversizes, maybe choose another machine, choose another nesting configuration, maybe the same you used before. Okay, and then choose another spindle maybe for that kind of the boards. Okay, so as you notice, all that happens in the machine section. Yeah, so that means that you can individually pick those settings for different materials. You don't need to create just a generic nesting tooling operation. You can be more precise and more flexible. Okay, so as you can see, I can copy configuration that I used before, and then I can apply it somewhere else, maybe on another material type. Yes, so that's how it goes. Okay, once it's done, I can choose the configuration, and you can see there is like option use nesting CNC equipment by material settings. So if on material settings I have chosen that this material need to be processed on the CNC, then we'll get CNC files. If I said that this material need to be treated on the nesting machine, then I'll get nesting layout. Or I can force to generate CNC or nesting, despite the fact which default settings is used for a given material. So we have like three options. Yeah, by material settings, and here I can have both CNC and the nesting, or I can force the system to generate nesting or generate the CNC files for that material. Then according options will be loaded from the database and used in the layout. So as you notice, all those changes happens in the material editor, and that's why we unlocked it in the trial version. So if you'd like to try how the things works, then you can just download the trial, and this trial will have material editor unlocked, because otherwise you'll have no option to change the settings. Okay, so now let's take a look at the nesting layout. Okay, now you can see how this will look like. Okay, that's the parts of our nesting layout, and you can see that nesting is different. We have another interface here. We have a size of the part, we have a size of the tool options, what we will use for each of the instances we have. Okay, so we can have a complete picture of what we do with what kind of tool and how. Okay, so it looks similarly as the browser of the assembly in Inventor. It's not actually the same, but it looks similarly. Why it's not the same? Because on the nesting layout, maybe I want to duplicate the amount of instances of some part, and then the structure of this nesting layout will be different from what I have in assembly. Okay, now there is a question how to convert the settings from older version to a new one. Basically, you can request a separate advice from our colleagues, or maybe you can request directly your partner, Inventor reseller, Woodwork for Inventor reseller, sorry, and they can provide instructions what to do in case if you want to migrate the settings. Basically, database will be updated automatically, but there's some settings which was not set before, like for instance bridges, what to do with the bridges. Yeah, do you want to use them or not? And that's why you need to add some options. Okay, so some manual tweaks may be needed, despite the fact that database will be updated automatically, but you may need some manual tweaks in order to make the system work. So again, if you need any advice, feel free to connect our partners, and we will provide all the information you may need. Okay, now let's speak a little bit about UI interactions. And first of all, you notice that we can interactively, you'll notice that we will interactively select the starting point and the tooling direction on the part. Of course, we can choose landing and withdrawal options, flip and rotate the part interactively. So it will animate the rotation and flipping. And you can move the part using cursor as well, which is in some cases faster than using a mouse. Also, if you have some operation on the back side, you will see their contours as well, which is very convenient. And you can pick multiple objects in order to apply the operation on them. You notice that on the side browser we will see some information about the material, about the desktop configuration, about the part code, position, etc. And of course, when you select something on the browser, it will be selected on the nesting layout and vice versa. Okay, so now let's see how it happens. So we can see that there is a browser which indicates the parent assembly information, the information about the part, information about the tooling, and here we can see the final layout of our assembly. Each part has some size information, the label with the code of the part. Yeah, so we can get all the information from the layout site, or we can see it on a browser as well. So we have names with their codes and the sizes of the workpieces. Okay, so let's do some changes. In order to do this, let's open the material editor again. So remember, we have some thickness definition. Okay, so here I can see what is the configuration used. So it says what is the config. Yeah, in this case it's the opposite one. Yeah, it's used for another material thicknesses and boundaries. So we can understand what we actually configured and what operations will be performed. Okay, so we have more information about the tooling. Okay, now let's see what will happen if I want to flip something. And I hope you notice, despite the internet compression, that the part was flipped using some animation. Yeah, it not happens in 0 time. Yeah, we have some nice animation which allows you to understand what actually happened. Because previously it was quite confusing when you just click and the part flipped immediately to understand what actually happened. Yeah. So now you can see that the part moves on their own, but it's not a magic. We're just using the cursor control on the keyboard. Yes, so you can just play a little Tetris game here in order to have a best layout possible. And you notice that each part have some connections, yeah, so some bridges. We can see them here in the layout. And if you want, we can add more bridges. Okay, like so. Or you can, of course, delete them. Of course, if you want, you can set a complete auto mode, and all the bridges will be set accordingly for the parts, like so. You can define how many bridges you want to have, what size of the bridge should be, and so on. And also, as I mentioned, we can choose a starting point, so interactively. In this case, I need to select the part I want to process. And you can see a little milling tool here. Okay, and you can interactively pick what is the starting point of each of the part. Okay, and of course, when you're happy with the results, you can choose the lead in option, direct or lamp, or lead out options. Okay, when you have chosen one, you decide what is the distance of the approach and lead out. Okay. When there is nothing selected, you will see just a red window which indicates that something needs to be entered. Okay. So if you want to group the parts somehow, you can pick them all, okay, and move them in the desired position, like so. So group operations is also possible. And of course you can flip the group of the parts vertically, horizontally, or maybe rotate them. And using the animation you can understand what actually happens. Because it's not happened all of a sudden, it just do some little animation on that. Okay, now let's speak a little bit about the nesting, yeah? About the Woodwork with nesting, which is the most feature-rich version of a nesting software of Woodwork for Inventor. So in this case, we may use it, for instance, for laying out the parts that are grouped in the assembly. So we can pick the parts we want to arrange and place them on the nesting layout. Okay. So let's use a nesting tool, and instead of picking all of the parts, I can remove the selection and only pick the facades. Okay, like so. Now the layout will be generated, and you can place the parts in the way you like. So we don't place them directly as an assembly because maybe you want to use one or another tooling options. Yeah, it depends what you'd like to actually get. So you need to lay them out in the manual way, but we have only those parts that you have selected. So you can just have more precise control on what you are doing. Okay, now let's take a look at the nesting BOM. This is another strong nesting feature, because you need to know how much workpieces you will utilize. Yeah? And the area on the assembly BOM is not the same as the area on the nesting. Yeah? So maybe you have part of 1 square meter which goes diagonally through the workpiece, and you need to waste all that workpiece. Yes, or maybe you have like a nice rectangular item that will fit perfectly. So that's why the nesting BOM and the BOM of the assembly is not the same. So we can generate BOM after the nesting using the same workflow. It means that we're using Excel templates in order to define how the BOM will look like. Of course, we added some new keywords and new keyword hierarchy, which allows you to have a best control possible. And you can generate the BOM files in order to merge them or to manipulate them in a different way. So we will speak about this function later. And also you have an option about the material usage percentage and included product, which means you'll get assembly list which contains those nested parts. Okay, speaking about nesting BOM structure, you'll see here that we have additional items in the VNest file. So we are operating on the desktop level, which is connected with the material definition. So on the desktop we have multiple worksheets. Each of those can have multiple instances of the same piece, of the same part. So the part definition is split into the multiple instances. Those can be placed on the multiple sheets on the desktop made of the same material. So finally, when you collect them all, we can calculate the total amount and summarize the final product definition. Okay, so that is the idea of how the BOM structure works. Of course, now I will not speak about the keywords because it will take a long time. So let's see how it actually happens. Okay, so we have a nesting layout right there with the list of parts you may see on the left on the browser. So now let's see that we want to generate the BOM. So for this purpose, I'll choose a template. Okay, like so. And say I want to do some changes, or maybe see how it looks like. Okay, so we have similar structure as in case with a regular BOM, but we're using different keywords. Okay, so we have a data description, as we have in the regular BOM. We have some consumption list, shows you how much material we wasted, what is the percentage, what material was used, and so on and so forth. Okay, so in other words, this is like a flexible way of producing the final report. Okay, so you can change the data in the way you like. Maybe you want to add some information, maybe it's more than enough, you want to remove something. And of course you have header information in order to define who is the customer of this manufacturing order, because it's not related with the model, it's related with the customer. Maybe the same person requested the same item, maybe another person requested the same item. So that's why this definition is separated. Okay, so now we want to just say that I want to get the report, and the result of this report generation will look similar to the template definition. Of course, we'll get the data beside the instead of keywords. Okay, so we have a layout. Okay, with the materials definition of each of the material on each of the worksheets and the quantity of them. Okay, so if we take a look at the consumption, we can see how much material we utilized. What is the area? In the part list, you can see the parts, obviously, with their length, width, thickness, quantity. Now, if you take a look at the included products, you can see the main assembly information here. Okay. And the materials used in nesting. Yeah. So in this case, it's empty. And the name configuration. Okay. So now let's take a look at another options we have here. We have up and down cut options and the compression tools. So what does it mean? If we utilize some material like a plywood, we may face with the case when the plywood is ripped off because of the tooling, if the tool is not so sharp. So we can face with the delamination problem. Yeah. So in this case, we are using traditional mill. We can just rip off the material. So what we can do instead? We can use up cut and down cut spindles or compression tools. So what they do, they just apply the cutting forces in the center of the cutting path. Okay, so you can see that we have an options like to choose down cut spindle, up cut spindle on the left, and in case if you're using compressed spindle, it's enough to just pick this compressed spindle. Now the next option is about image printing. So we can print the images for selected items. So we can print them in the raster format, in a bitmap, or we can pick them and print them like in scalable vector graphic format, yeah, which is like not depending on the scale. Okay, let's take a look what will happen here. Okay, so there is an option what you can do. We can print the image to a file. In this case, I can pick the naming scheme. Okay, like item piece code, SVG or PNG. Okay, and then I need to just apply the changes. Okay, once it's done, I can select the part I want to print. Okay, like so. And once I picked all the parts, later we will see all the sheets with the parts. Later we'll see what is the layout. So there is the folder with the PNG files, like so. And we can see the image. So there is the black Windows scheme used, so that's why we have a black border around. But basically, if you have light scheme, you will see a white background, so maybe it will look a little bit differently. So if you want to see individual parts, you can see they are printed in SVG format, like scalable vector graphic, and I can open them with some software. Okay, like in this case, I can just open them using browser. Browser understands in most cases SVG files, so we can see their content. Okay, and when I'm using the another option to print entire sheet, I can print them in the PDF format as well. So I give a name, okay, like so, and we can see the layout of the parts. So that's the layout in the PDF file. You can send on the email, for instance, so you don't need to have another software which understands that kind of the files. So it can be sent to management or maybe some accountants and so on. Okay, now let's take a look at the label printers, one of the important features, because when you do a nesting layout, it's important to understand what part is what, yeah, because when they are all lying around, so it's hard to see what is the difference. Maybe you have a little bit different workpieces, but they will be translated in totally different parts. So that's why we want to make sure that there will be some differentiation. Okay, so let's take a look at what will happen in case if you apply labels. Okay, so again we have a layout. We can use some template, specially defined template, which will be used for the labels, or in other words stickers. And in the label template we have some options about what information we want to see. Okay, So that's the layout of the parts. Okay, we can see them here. Okay, so all the parts with the according information are shown. So the way how they look like can be easily configured using the template definition. You can see how it looks like. We have an image, size, code, name, type information, and so on. So you can adjust the way how it looks like. Okay. Now if I'll choose another template, the information will look a little bit differently. We can basically see the part and its position beside. Okay, so let's see how the layout will look like in this case. Okay, so there is the part on the left, and there is the position of the part in the layout on the right side. Okay. So that's the easy way to understand what part is placed where. Okay. So that's the options you can choose from. Yeah, you can use just a list of the parts, or you can see their layout as well. Okay, very nice and convenient way of printing the labels. Now let's speak about the files. There's two versions of the nesting files, nesting layout and just nesting. So nesting light can save and open just its own files. Nesting, on the other hand, can save and open and merge nesting and nesting light files as well. And we have something more. We have a tool which we'll call like printing utility for Woodwork for Inventor, which will be used in near the CNC machine. So you don't need to have a Woodwork installed. You can just have a printing utility running, and then open the nesting layout file and apply printing in order to get the labels or something else. Okay, so what it allows you to do, it allows you to open the files, generate BOM, allows you to print the pictures, the images, and pick the parts you want to generate the images for. Yeah, so say you want to create a label for one part, and you can select it, and it will print the image for this label for this part. Okay, so let's just quickly compare the features side by side. You can see that in both versions we have tooling in the material. We can apply the bridges and onion skins. We can interactively select the starting point, lead in and lead out options. We can define up and down cut properties, use compressed spindles, and see the options, see the properties of the item on the nesting. So what is the differences? The differences is between the files. The nesting light works only with the nesting light files. Okay. So, but also there is a big difference in the BOM generation. Nesting light cannot generate BOM files. So if you want to get a structure of the assembly, of the nesting layout, you need to use nesting, not nesting light. Okay. So also about the labels, the generation of the labels is only available on the nesting. Okay. That's the differences. Now, just to conclude the information you saw, let's speak a little bit about the licenses. Okay, so the very basic version of a Woodwork for Inventor, it's not a official name, basic, but I just call it for clearness. Have all the features you may need for a design, like panel dress up, material assignment, hardware placement and hole generation, iBox, BOM, drawing generator, and so on. On top of that, we have another option, Woodwork for Inventor with CAM, which have a CAM functionality and nesting light features. Okay, and more feature-rich version is called nesting, which have nesting options. Okay, so that's the configurations you may have. So again, Woodwork for Inventor Basic, which have no nesting at all. Woodwork for Inventor with CAM, which have CAM and nesting light functionality, and full feature version of a Woodwork for Inventor nesting. And there is some good news for you. Now we have some promo which allows you to purchase Woodwork for Inventor nesting at Woodwork for Inventor with camp price. So this special offer is time limited. It works only until April 31st. So please ask your resellers about more information about discounts. So all the things that we saw can be trialed out in our web page. As I mentioned, max featured version can be downloaded from the web page, and there is no limitation on the material editor because all the features are placed here. So thank you very much for joining. Be safe and see you soon. Good luck.